Okay, they say a lot of things here, but what's relevant is this joint PDF, and you have to find variance of y given x equals 0.75. And in order to find the variance of this, you have to find the corresponding density function, which would be f of y given 0.75. When you say that, it's understood that whatever is given is the other variable, the variable other than y. So f of y given 0.75 is f of 0.75 y divided by fx 0.75, where fx at 0.75, so that's the basic A given B formula. A and B is like 0.75 for x and y for y, and in the bottom you have the x probability being 0.75, which means the marginal density of x at 0.75. So the marginal density of x at 0.75 is negative infinity to infinity, f of 0.75 comma y. Remember, 0.75 is for x. When you have marginal density, that's just in one variable. So that's all in x. So, and it's found by integrating the joint PDF over the other variable. So in general, fx of x will be negative infinity to infinity f of xy and dy. But since we know that x is 0.75, so I just had 0.75 in the x spot. And you integrate the other variable out. That is, you integrate the y out. So that would be 0. So if now you look at the y definition, when x is 0.75, so x would be 0.75 over here and here, and y goes from 0 to 0.5, and the function is 1.5. And when y goes from 0.5 to 1, the function is 0.75. And this holds for whatever x values you have between 0.5 and 1. So the significance of 0.75 for x is that it's between 0.5 and 1, which means you're looking over here, because the other two are for x between 0 and 0.5. So when y is between 0 and 0.5, the function is 1.5. So between 0 and 0.5, the function is 1.5. And when y is between 0.5 and 1, the function is 0.75. Between 0.5 and 1, it's 0.75. So the integral of 1.5 is just 1.5y. When you substitute the y values, you get that. Similarly here. And we end up with 1.125. And now you substitute this in equation 1. And so you get f of y given 0.75 would be f of 0.75 comma y over 1.125. And now f of 0.75y means x is 0.75 and y is y. And that also changes when y is between 0 and 0.5. The f, which is the joint PDF, was 1.5, remember? We're always looking at the bottom two. When y is between 0 and 0.5, the PDF is 1.5. And when y is between 0.5 and 1, it's 0.75. So 1.5 and 0.75, depending on where y is. And 1.5 over 1.125. So basically we're substituting this one, the numerator, for whatever the y range is, in the y range 0 to 0.5, this numerator is 1.5, and then in the other one it's 0.75. This ends up being 4/3, this ends up being 2/3. So now we have the complete density function that we need, which corresponds to the variance we want. Remember, we wanted variance of y given x equals 0.75. And now we will use this corresponding density function to get the two quantities that we need in variance. Remember, E in general, variance is the expected value of the squared variable minus the expected value of the variable whole squared, right? E of x squared minus E of x whole squared. And in this case, since we need variance y given x equals 0.75, so we will need expected value of y given x equals 0.75 and the expected value of y squared given x equals 0.75. So expected y given x equals 0.75 would be negative infinity to infinity, y integrated against the density function, f of y given 0.75. And we have seen that it breaks up like this. So when y is between 0 and 0.5, it's 4/3. And when y is between 0.5 and 1, it's 2/3. And integrate against y because you're finding the expected value of y. So the integral of y is y squared by 2. And then when you substitute the limits, you end up getting 5/12. Similarly, we get expected value of y squared given x equals 0.75. So the same thing as above. Now instead of y, we are having y squared in the integral. And that ends up being y cubed by 3 and the constants. And eventually the y squared expected value is 1/4. And then we have our basic variance formula. Variance of y would be variance expected value of y squared minus expected value of y whole square. And everything is at given x equals 0.75. So you substitute this value was 1/4, the other one was 5/12. And we end up being 0.076, which is choice C.